Right, ladies and gentlemen, I'd like to welcome you back to my YouTube channel. So, my brother, I'm sorry to take long to reply your what to call your question. So I've been busy, and I think you said we must look at this one, and I must use my own dimension. So as far as I'm concerned, it's that you didn't explain to me. But as far as I'm looking at this pipe, steel pipe joint of yours. It's a right angle one. It's a right angle one of the very same diameter. Very much important to take a very close look on that one. And I couldn't manage to have a printout of this one. It's a photo. You've just forwarded a photo to me. You said you don't understand it's a drawing. So you said you must use our own what to call dimensions. So I went to a textbook of engineering drawing. I found similar problem. So what I had to take a closer look at is that this diameter is the same as this one, as the branch pipe. So this is the main pipe, and it's being connected at a right angle. So it's a T joint actually of the very same diameter. So this T joint pipe is of the very same diameter. So I went to a textbook, you understand, so that I get the proper dimension. So it's this one. It's a T joint of this very same diameter. So the very first thing that we are going to do here, we are going to draw the given view. So you can actually see these views are given in third angle orthographic projection, my brother. So you must understand when we say, you told me that you don't understand anything, which means I assume even orthographic, you don't understand it. So just scroll down along my videos. You are going to find a video that will be good for you where I'm addressing orthographic projection. You understand? So this is the symbol of third angle orthographic projection. So remember, at third angle orthographic projection, we do not have the word left. You get it? So we have a front and we have the front and the top. So this is not your right. This is the auxiliary of your front view. You get it? So we are going to draw this. Let's draw them using a scale of 1:1. So it's not that much clear, but I'll try to for instance, I don't say this is this 95 or okay. So let's start to draw. I am going to start with what, my guy, with a top view, So the top view is diameter how much? This is diameter 56, I think. From here, yeah, it's diameter 56, this one. Remember, they are of the same diameter, 56. So have you calculated? So which means in our model, this is diameter 56. So we're going to say 56 divided by 2, you are getting 28. So you take your drawing compass, you open it to 28. My guy, finish this one now, faster. 28. There is my 29. This is 28. Get it? So then I'll come just up here and draw the diameter and draw it dark. Get it? So I mark where I was placing my drawing compass. Where was I placing my drawing compass? Right there. So I'm going to draw. My table is too small for me. I draw a horizontal center line. Center line. How do you draw a center line? You draw it long, short. It's the center. You understand? So I don't know. Do you understand? If we are talking about the center, we are talking about what? If you are completely blank, it's your first time to do drawing, just scroll down along my videos. You're gonna get even here on YouTube, I've got so many colleagues that are also addressing mechanical engineering drawing. So you just browse a lot, you are going to get help You understand? So I'm going to draw a vertical. So a center line, always draw short, long, short, long, short, long, short, long, long. So this is actually Boilermaker drawing, you understand? But do you see that I'm retrieving it right from an engineering drawing under the topic of interpenetration, you understand? So since there are, so in other words, we threw this one with my textbook. This one is diameter 55, so I'm going to record record how much, 20 millimeters. So we separate our views with 20 millimeter. There is my 20. So I can draw a constructional line, faint. So it has to be faint. When you draw a faint line, you hold your pencil here, then you pull, you understand? You hold it at the end, you understand, my guy? So then from there, what is going to happen now, I can project this one vertically faint down. There you go. I can project this one. Your circumference is this point. So you try by all means to be accurate. You get it, this point, this one, where your circumference point exactly cuts or crosses this horizontal line of yours, where it crosses what your circumference part is your point. Why am I trying to emphasize that? Because I've seen students, you tell them take this point, they will be just doing like this. You understand? Do you see that it's not accurate? You understand? Or you see them doing like this. You see? So it's not accurate like that. You understand? So from there, I am going to have this one solid dark, my guy. So from here till here, solid. You understand? Because I want to have a clear understanding, my guy, between a solid line and a constructional line. You get it? So from there, I can come and have what? A height. Because this is the top, this is the front. So from here till here, I must have what? A height. So if I'm given from here till here, it's 46. 46, because I'm not quite sure about this one. It seems to be not clear whether it's 80 or it's 90, but I'll rely to this 46. So from here till here, it's a half of 46. From here till here, it's a half of 46. You get it? So I can come along the vertical center, 45. There is my 46. I mark. Then I can come and record the other 46. 45, 46, right here. So at the first one, I can draw a horizontal center line. So draw it a little bit long, because you're still going to need it when you draw your auxiliary view. Like this, you understand? So now after that, the second 46 is ending where? Right here. So I can have a solid line. So it's the bottom part of my of my front view, which is this one, from here till the A1, which is that one. Then from there, yes, it's clear enough. So now I can come and have this one solid from there till there, as you can see it. I can even use my 30mm ruler, because of I'm actually drawing it on top of a constructional line. On top of a constructional line, you understand? So from there, I can come and be like, from here till there is how much? We are given the dimension, you understand? So from here, my guy, till there is 30mm. It's 30mm, you understand? So you are going to record this 30mm from here, going this side. There is my 30mm. Then at 30, I can construct a vertical faint line. Go faint. Right. After that, I will then come back to draw the auxiliary view. I can come back to draw the auxiliary view, which is diameter is still the same diameter of what, of remember from here till here is what, is 56, which means it's the same diameter. So the auxiliary, it will be the same diameter as that one that you've studied. So you can simply come back to place your drawing compass here. Remember this T joint pipe of yours, they said they're of the very same what, diameter. They're of the very same diameter. So now I can come and place it here. Just place it here and throw the what, the diameter. So the auxiliary views, always draw it faint. The auxiliary views, you must always draw it faint, because it's not part of your drawing, it's just a constructional line. So now I'll draw the vertical center line of my auxiliary view, front view, and project this line up until it crosses the horizontal faint line of your top view. So now what is going to happen, I'll take this one, this point horizontally, and that one horizontally. There you go. So in other ways, which means I can come back and have this one solid from here till here. You get it? Which one is this one? Come back is that one, my guy. This one from here till here. You understand which is this one from here till here. So now I see this one from here till there, from there till there is automatically there for you. So come back here and have this one solid, and have that one solid. So TikTokers, I'm sorry, some of your comment I cannot see them because of I am actually concentrating on the paper other than on the screen. You get it? So if you think I'm ignoring, no, sorry, I'm not. You understand? I might not see your comment. So from there I'll come back to have this one solid, my guy, from here till there, from here till there. You get it? So which is what? Which is this one? Which is this one? We've already drew it. So let's go up to our top view. Remember, given in third angle orthographic projection, which means this is top, this is front, your right, it should be somewhere. So this is not your right, it's an auxiliary view of your front view. You get it? So from there I'll go back to my top view and get the what, the auxiliary view as well. So I have to, it's going to be the same in terms of so I just come and record it here. I come and place it here where the vertical and this horizontal center line there by my what, my top view, perpendicular to each other. I place my drawing compass and draw it faint as well. You understand? So I'll come back and exceed this center line of mine, because the center line mustn't end like this. Center line, they must always exceed what you're drawing like this. You understand? So if it's like this, it's not proper. So a center line must always exceed so that you get that point on top of the circumference of your side. You get it? So there I have. So now I'll take this one horizontally. There you go, faint, and take this one faint. There you go. Once it touch look, so there by my top view, look, this line is exactly at that one. Why? Because of the set, they are of the same diameter. This T joint pipe of yours is of the very same diameter. Understand? So that is why it's going to touch them. So in other ways, I can have this one without fear or favor, dark from here till there, and from here till there. Get it? Which one is that? This one. See, I'm trying to be very slow, explaining each and every line that I'm altering. So now I can have this one solid, which means from there till there, solid. You get it? So from here till there, solid. Right. So in other ways, we've through the give and use. You understand? So now we have to express the line of interpenetration. Where's my question? The line of interpenetration, which is that welding arc. This phone, it's not open. That welding arc, my guy. So check, isn't it? This is what we are addressing. This is what we are doing. So why it's not clear enough? So now we are going to express or show that welding arc where you're supposed to weld, you as a welder. You understand? So that welding arc. So graphically, how are we going to show that? Graphically, how are we going to show that? So in Boilermaker, every time when you see a cycle, you must know what you have to divide it into 12 equal parts. And it's because along the circumferences of that diameter or that cycle of yours, we have points. We are having points. Understand? So we are going to divide the circle into 12 equal parts. So we've got two methods of dividing the circle into 12 equal parts. Whether you use a drawing compass, or you can use what you call your set squares. You can use the set of your squares. So on this, I can use, since it's Boilermaker, let me use the drawing compass. So if you are using a T-square, let me explain that. If you are using a set squares, so you can start with this one, angle 30 degrees clockwise, like this. Then you direct it up until at what? At your let me just do it. There you go. Direct it up until at your point center, where these two centers are perpendicular to each other. So you draw it like that. So now I'm going to flash it up until at the same point again. So I draw faint. You understand? So you have to be accurate. You understand? So I firstly drew this one, then now just flash it. There you go. Then from there you twist it. This is angle what? 60 anti-clock, isn't it? So now twist it like this. Twist it like this. So now I come and do this one. There you go. Which is angle 60 in a clockwise direction. So the last one, you come in. You understand? There you go. So I prefer this one since it's even accurate. You understand? So that's how we divide the circle into 12 equal parts. So on the top, on the auxiliary top view, let me use a drawing compass. So my guy, I would first start with this one, this point, and further extend it to the center. Then I come and strike an arc here, and strike an arc here. You get it? Then I come on the upper one. Start with the vertical one, place it there, further extend it to the center, strike an arc here, strike an arc there. You get it? So now I come on the horizontal one, place it here, further extend it to the center, strike an arc here, strike an arc here. The last one, place it here to your center. Be accurate. There you go, and there you go. So you can actually see which one is faster than the other one. So that's how we divide the circle into 12 equal parts. What I did down here is still on the same thing as I've done up there. So now I'm going to do what? Join this point with that one. I join this one with that one. Faint. I join this one with that one. So I join this one. All of these constructional line right from your auxiliary views, they must be faint. They must be faint. So there you go. You get it. So now the numbering is you are not restricted to you're supposed to use numbers or alphabet or Roman figures, you understand, as long as your numbering is consistent, you understand. So I'll start numbering what right from my front view, because it's very much important. The numbering system of your auxiliary front must mesh or must tally with what, with the numbering system of your auxiliary top view. You get it? So remember, what are we doing? What are we doing? We are looking for that line of interpenetration, that welding arc, that one that is somewhere there, you understand. And if we can draw this one orthographically, let's say the question said draw the front view of this pipe branch, TP pipe branch, so of the very same diameter. You can actually see what that welding arc is gonna come as a straight line. It's not going to be in a certain arc. Why? Because of these two pipes they're of the very same what diameter, so it would be a sort of a straight line. So even in our solution we have to get something of that nature, you understand. So let's go and see what are we getting. So excuse me. So we don't know what you are doing, we are just following the protocol. So if I have a 0 here, I go and I have a 0 here. This is auxiliary front, this is auxiliary top. Remember, it's given in third angle orthographic projection. Even if it's given in first, my guy, it should be still one and the same thing. The protocol is the same. So if I have a 0 here, I'll come to say this is my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, back to 0. You understand? You understand? So now what is going to happen? I'll take these points of the 11 and the 1 in the same line, take them horizontal, the same line. Then the 2 and the 10, there you go, same line. And then 3 and the 9 already there, which is the center. Why do I like to use this center method, and I draw it dark, so that I will know what I've got 3 lines after the center and I've got 3 lines before the center, you understand. So 4 and the 8 in the same line, there you go. And the 5 and the 7, the same line, there you go. So we want to express the line of interpenetration there by our front view. So the line of interpenetration is always expressed in your front view. You get it? You get it? Which is this one. Even the photo, you send it to me, my guy. You can actually be like, this is my front, the top, it should be this side, you understand. So now let's see what is going to happen. So the protocol, all the points from the auxiliary front, they are just going horizontal straight. So now let's go where at the auxiliary top. Now auxiliary top view, so the number must tally with what, with this one. So if I have a 0 here, so there it goes, this 0 is going straight, so must intersect with what, with the 0 of auxiliary top view. So all the points all the points right from my auxiliary top view, they will be directed horizontal, my guy. Once they touch the main pipe, you understand, because this is the main pipe, this is the branch pipe of the of the very same diameter. Once they touch the main pipe, they will change direction, they go vertically down, you understand. They will be going how, vertically down. So if I have a 0 here, there it goes. So once it touch the main pipe, it's gonna go up, so which means I must be having what, a 0 right here. So here I was going anti, here I would have to go clock. So now this is going to be 1, you get it, 2 and the 3, 4, 5, 6 and the 7, 8, 9, 10, and 11 back to 0 at your starting point. You understand? So now what is happening? We are going to take point 0. Once it touches the main pipe, goes vertically down. Must intersect with what? With the 0 of my auxiliary front view. So there it goes. It's already there, isn't it? So which means my 0 point is right there, which is 0 point. 0 and what? And 12. Let me name them like that. 0 and 12. Right. So where is my point 1? Go back to your auxiliary top. Point 1 in the same line with what? With 5. So there you go. So once they touch the main pipe, you're gonna take them what? Vertically down. So there you go. So this is what? This is 1 in line with 5 must intersect with what? With the what? With the point 1. There you go. Trace it. Simple, straightforward. So there you go. So which means I have what? A point right there. So these point, plot them, make them visible. You understand? Because we are answering a question here to an examiner. We mustn't just come with a solution. There must be stepwisely. How did you end up here? So there must be constructional line visible there. You don't erase them. After you've gotten your solution, it doesn't mean that you have to erase them. You submit your work with them. You have to. There must be constructional line as well as points being plotted, if there is such. Okay, now let's go to point 2. Point 2 right from the auxiliary top. This is it. Point 2 in the same line with point 4. You understand? Just a little bit. So there you go. Once you touch the main pipe, you go vertically down. So vertically down, which is this one. So there you go. So this is point 2 must intersect with the 2 of auxiliary front. So which means I have what? A point, my guy there. My brother. You understand? Which is point 2. So point 3, which is the center. You understand? So which is the center. Trace it. There it goes. Once it touches the main pipe, it's going vertically down. Must intersect with what? With the point 3. So it's the center. This is 3, It's the center. You get it? Then point 4, trace it. Point 4 is actually in the same point with what? With the line of 2. But in the auxiliary front is not. So there is my point 4. Point 4, trace it. There it goes. In the same line with the line of 2. Intersect with this 4. So I have what? A point here. You get it? So point 5, auxiliary top, there it goes, there it goes. Once it touches the main pipe, goes vertically down. Must intersect with what? With the 5 of auxiliary front. Point 6 in the same line with the 0, there it goes, the one you started with. Must intersect with what? With this one. You get it? So that's how you get your point. You understand? So now, you can use your flexi curve to join them, but by look of things, it would be a straight line. Let's see, is it a straight line coming? You can actually see it's coming. You see, with the rule, you can actually see it's coming. You understand? So there you go, straight line, my guy. So even up here, you can actually see it's coming. So there you go. You understand? So this so this one, it won't be dark from here till it won't be dark because of it's a cylinder. It's a cylinder pipe. You understand? You are joining a cylinder pipe with a cylinder pipe in this case. You understand? So that was it. And even in your work that in your practice that you've done at your workshop, you can actually see if we were to draw the front view of this pipe. So this welding arc, that line of interpenetration, it will be in a sort of a straight line. You understand? You understand? So you said I must use my own dimension. So you must get something of this nature. You understand? Something of